Lesson 3, Greatest Common Factor. So greatest common factor, GCF, is the highest factor that can go into two or more numbers. And so factors are the numbers that a number can be divided by. So when you're finding the greatest common factor, there's two ways you could do it. The first way is to write down all the possible factors. So for 16 and 84, we can write down all the factors that go into 16 and 84. So the way that I do this is I write my 1, and 1 times 16 is 16. And I write it on the end because I know that's the biggest possible number that can go into 16. Then I work my way down. So 2 times 8 is 16. 3 doesn't go into 16. And 4 times 4 is 16. And because I got to the middle there and there's no numbers between 4, we know we're done. So 1, 2, 4, 8, and 16. Now we're going to do 84. So we have 1 times 84. 2, take 84 divided by 2, and you get 42. If you take 3, 84 divided by 3 is 28. 84 divided by 4 is 21. 84 divided by 6 is 14. And 84 divided by 7 is 12. There's hardly any room in there, and thank goodness that's the last one. Because 8 doesn't work, 9 doesn't work, 10 doesn't work, and 11 doesn't work. So since there's no numbers in between, these are all the factors of 84. Now to find the greatest common factor, we circle the highest number that's the same on both, which is 4, so the GCF is equal to 4. So that was example 1 and 2. Example 1 was finding all the factors, and example 2 was finding the GCF, so we circle the biggest number. Example 3, we want to find the GCF between 126 and 144. So we can do this with prime factorization. So to do that, we have to find the prime factorization of each number. So let's take 126, and I'm going to use division of primes. So divided by 2 equals 63. 63 divided by 7 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So 126 is equal to 2 times 3 times 3 times 7. Now, when you're finding the GCF, you do not have to put it in exponent form. You need to leave it like this. Now we'll do 144. 144 divided by 2 is 72. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So the prime factorization of 144 is 2 times 2 times 2 times 2 times 3 times 3. Now to find your GCF, you're going to circle the numbers that you have common in both of them. So because I have a 2 here and a 2 here, we write a 2 for our GCF. There's no more 2's that you can pair up. So now we're going to pair up the 3's. So we have a 3 and a 3. So we're going to multiply it by 3. And we have another set of 3's. So times by 3 again. So your GCF is going to be the same as 2 times 3 times 3. 2 times 3 is 6. And 6 times 3 is 18. So that is your GCF. Our next one is 7 and 20. So the prime factorization of 7 is easy. 7 divided by 7 is 1. That's it. So 7 equals 7. Prime factorization of 20. Divided by 2 equals 10. 10 divided by 2 equals 5. And 5 divided by 5 equals 1. So 20 is equal to 2 times 2 times 5. Now, when you don't have any numbers that are the same, you can't find a pair between the prime factorizations, your greatest common factor is 1. 1 can go into both of them, but nothing higher than that can. Example 4 is a word problem. So when you're doing word problems, it's important you read the question all the way through first. Then, with GCF problems, you have to look for hints that it's greatest common factor. So the things that you're looking for is if you need to factor, if it's dividing into groups, if a number gets smaller, or you're arranging into rows. Any of those kind of things are hints that it's a GCF question. So here's our example. You are making a quilt that is 1,250 centimeters by 1,050 centimeters. You want to cut the fabric so that each quilt patch is the same size square. What is the largest possible patch you can cut? So because you're dividing into groups, we know that this is a GCF problem. So I would even write that down so you know for sure that it's GCF and you know your reason why. So we're going to find the GCF of these two numbers. So first, 1250 divided by 2 is 625. 625 divided by 5 is 125. 125 divided by 5 is 25. 25 divided by 5 is 5. And 5 divided by 5 is 1. So we have 2 times 5 times 5 times 5 times 5. For the second one, we have 1,050 divided by 2 is 525. 525 divided by 5 is 105. 105 divided by 5 is 21. 21 divided by 7 is 3. And 3 divided by 3 is 1. So we're going to put these in order. So 1050 is equal to 2 times 3 times 5 times 5 times 7. Now we want to find the GCF, so we're going to bring it out in pairs. So we have a 2 here and a 2 here. So we can put a 2 in our GCF. We have a 5 here and a 5 here, a 5 here, and a 5 here. Nothing else is the same, so our GCF is going to be 2 times 5 times 5. 2 times 5 is 10 times 5 is 50. So the quilt patches will be 50 centimeters by 50 centimeters.